Hello, this is Farhia.
And Pierina.
And we're going to teach you about the
Doppler effect.
From Unit 7, Harmonic Motions, Waves, and Sound. The Doppler effect is when relative motion creates a change in frequency. And here goes an example.
When wavefronts come closer together, the frequency or pitch seems higher. When wavefronts are further apart, the frequency or pitch seems lower. This is why when an ambulance gets closer to you, the frequency or pitch of the siren is higher, and when it's going away from you, the frequency or pitch of the siren is lower. The applicable formula is the force of the detector equals the force of the source times the velocity plus or minus the velocity of the detector over the velocity plus or minus the velocity of the source. On the numerator, if the detector is traveling towards the source, it's positive. If the detector is traveling away from the source, it's negative. On the denominator, if the source is traveling away, it's positive. If the source is traveling towards, it's negative.
Example is a boat is moving towards a stationary submarine at 20.5 meters per second. The submarine exists at 4.7 kilohertz. The speed of the sound wave is 1,582 meters per second in water. What frequency will the boat detect?
Our diagram of the problem. The boat is traveling at 20.5 meters per second towards a stationary submarine, and the speed of sound wave in water is 1,582 meters per second.
Our givens are f of s is 4,700 hertz. F of s is the frequency of the wave that the submarine emits. V of s is 0 meters per second. V of s is the velocity of the submarine. V of d is 20.5 meters per second. V of d is the velocity of the wave. V equals 1,582 meters per second. V is the speed of the sound wave.
Our equation to solve is f of d equals f of s times v plus or minus vd over v plus or minus vs.
It's plugged in. F of d equals 4,700 hertz times 1,582 plus 20.5 divided by 1,582 minus 0. For the numerator, you add because the boat is going towards the submarine, and for the denominator, you subtract because it's also going towards the submarine. Now in algebra, f of d equals 4,700 hertz times 1,602.5 divided by 1,582. You add the velocity of the wave and the velocity of the detector to get the numerator. Then you subtract the velocity of the source from the velocity of the wave to get the denominator. The next step, you multiply the frequency of the submarine emits by the quotient of the previous step, which is 1.013.
Once you multiply the 4,700 hertz times 1.013, you get a final answer of the force of the detector being 4,760.9 hertz.
We've concluded that as you approach the submarine, the pitch seems higher than what is actually emitted.